Matlab or something. So like I feel
Yeah,
like I'm a
so
UI.
I'll show you guys what to do, right? Let me just talk a little bit about it, and then I'll show you guys what to download and install. So you'll do that for homework, because I don't want you downloading
That's
during the class and then, slow your internet up and then the video starts sticking up, right? Okay, so let's say we created a new document .txt, right? So when we create a new text document, the extension is .txt, right? Now what we can do, we can just rename this file. Let's say text file. Okay? We can rename text file to .m, right? TEXTFILE to .m. And .m is the extension for MATLAB live scripts. So this is important for MATLAB files, right? And what we can do with this MATLAB file, let's rename this one to a .m file. .m. And you can see that it automatically changes to a MATLAB icon, right? Now we can open this and it'll open up with MATLAB and you can edit it. Of course, alternatively, you can just open it with your text document, your text editor, and you can type MATLAB code in here, whatever MATLAB code is that you'll be learning throughout this class. And then you can use MATLAB to run it or compile it. Okay, so now to do this, you might need to go into your PC, maybe computer view, and you're gonna have to check this box here, file name extensions, to show the .text part and change it to .m. If you've done programming before, this is something that you're familiar with, right? So .m is the file type for MATLAB. Now, what we have here in MATLAB here, let me see if I can get the text bigger. No, all right, I'll adjust that for next class. But what we have here is the command window. Now, what the command window allows us to do is execute live code. So if I type 3 times 5 in here, it's gonna just execute that code, 3 by 5, and gives me 15. And this is how it is with most high-level programming languages. In Python as well, if you type something like this, it should shoot out 15 as well, right? So as opposed to writing code down in a text document like this, right? Changing the extension and executing it later, we can execute code live. And this is a great way to train and test your code out before you create a script that you might want to use over and over and over again. Right, so let's go through some basic live commands and use MATLAB as a simple calculator. Right, so the first one, multiply two numbers, 3 and 5. Of course, we can use other numbers, 4 and 6. And I get 24. Now, there's this other thing in programming, right, called a variable. Now, in mathematics, we know variable as x. We can say x is equal to 2 when x is equal to 2. It affects the function in this way, or the function evaluates to something else. So similarly, in programming, we have these things called variables. Let's think of a variable. Let's just say x, right? And we say x is equal to 2, okay? X is equal to 2. Now, we want to say, what's x plus 5? Well, since x is equal to 2, then x plus 5 should be 7, right? So we can start seeing how MATLAB can be useful to do our simple calculations, and we can use this calculator. We can store variables. We can do operations like this. Of course, we can do the other operations as well, right? We can do things like 7 plus 3 is 10. Let's see this up here. 7 plus 3 is 10. We can also do subtraction. 7 minus 2 is 5. And we can do things like that. And of course, we can do really big numbers like 120. 3 times 55. And that'll calculate that very accurately, right? All right, now, because variables are just places in memory that we store data. So if I refer back to x, like I just type x back into my computer and I press equal, it's going to spit out back 2, because we previously, right? We previously stored x as being equal to 2. right? Somewhere up here, x is being equal to 2. So when we type that back, right, it's going to spell out 2. Now, if we assign x to be equal to 3, what that does is it takes the value 2 out and it replaces it with 3. Right? So if we type x now, it's going to be equal to 3, right? And that changes. Now that allows us to do a very cool thing, which is reassigning the value of these variables, right? So we can do x, it's equal to the current value of x, which is 3, plus 1. So that way we can increment the value. And if we were to run this command again, right, it'll move up to 5. And if we run it again, it'll be 6, it'll be 7. Now, a great way to run through back old commands, and you'll find it when you download this and do it yourself, right, is just press the up button, right, to cycle through all commands, right? The up arrow key. And now if you press X, it's X is equal to 7. So variable is just a placeholder, a thing that we can put numbers into, right, and change them as we see fit. And we can use the variable to just hold values to do our calculations, and we can change them up, right? So maybe you want to do a calculation. Let's say you're in mechanics class, right? And the constant for gravity for a specific location, like Guyana, is 9.79, right? But then you move around the world and you're in England, and now the constant for gravity is 9.81, right? So you can just change that variable to be a different value, right? So you can change gravity from 9.79 to 9.81. So that's what it is. It allows you to change, and it can be varied, right? You get it. So now here at the side, we have the workspace, right? This thing here. That doesn't there. Okay, so here at the side is the workspace. And what you'll see is we have two variables here. We have A and S, and we have X. X is that same variable we were playing with here. X is equal to 7. And you can see if we change, let's say X is equal to 23, of course, the value of X change, and it displays it in the workspace. So what the workspace is a summary of all the different variables we have. So let's create a new variable M and equate that to 45, and it'll pop up in the workspace. We have X is 23 and M is 45. Then we can do operations like a new variable Y is equal to M times X, right? And we can get 1035, and a new variable would pop up, right? So you can see how all these tools can be useful. Now, as well, there's this variable A and S. So if we just were to do some random calculation like 8 divided by 4, 8 divided by 4, of course, that evaluates to 2, but the variable that is assigned to by default is A and S, which is short for answer. So your answer is equal to 2 for this calculation we did. Okay, and all of these are just stored in the workspace. Now, if we were to type clear, we see all of those disappear. What that does is it clears the memory, clears the workspace. So now if we were to type Y and press enter, we wouldn't get any value, right? Y is an unrecognized function or variable, meaning that they don't know what Y is. And if you press X, same thing, they don't know what X is. M, they don't know what M is, right? They don't know what you're referring to because these variables were never created and no values were assigned. So the clear function clears the memory, clears the workspace. Now, another important one is CLC. What that does is it clears the command window. So let's say we had a lot of function. We said X, let's assign it back to 7. M, let's assign it back to 45. And Y is equal to M times X, which is 315, right? Now, if we type CLC, what happens is that clears the window, but the workspace still stays valid, right? So again, X is still 7, Y is still 350 and M is still 45, right? So CLC clears the window, which would be good. Maybe you typed a lot of stuff and it's too much stuff on the screen and you just want to tidy up a bit, right? You type CLC and it clears the window.
Sir,
Yeah, go ahead.
I have a question. To clear everything, you type clear.
So clear clears the workspace here.
And the command window as well.
No, it doesn't clear the command window. So let's just type some 7 by 8, right? So if you type clear, right, it clears the workspace alone. It doesn't clear the command window. Right?
Okay, that's just what I want to know, because I want to know if
clears everything. Yeah. Good.
CLC
So
will just
now,
clear the command window.
yeah, CLC just clears the command window, not the workspace, right? So I know you guys probably wondering, how am I going to remember all this commands? So of course, I'll send you guys a handout, right? And it'll have some tasks and you can go through all the tasks, right? As homework and refresh and get to practice these commands. Because I know you guys don't have the software, right? Okay, good. So now about the software. Now, UG doesn't have a license for Matlab for students. So you can go online. Let me bring this down a little bit. Just search Matlab, M-A-T-L-A-B, right? Not M-A-T-H, right? So M-A-T-L-A-B. And you can go to the Mathsworks side. You can sign up as a student and you can get a student edition, a student trial. Alternatively, you can just search Octave, right? GNU/Octave and download the Octave software. Now, Octave is an open source alternative to Matlab, and the code that we type in Matlab executes essentially the same way in Octave. Maybe some of the syntax might be slightly different. So certain things, you'll see as we go about, maybe some square brackets might need to be curly brackets and things like that, like the syntax, like the things we type out might be slightly different in Octave, but for most part, it's the same, right? So if you don't want to download Matlab, you can download Octave as well, right? So I'll send you the link for Octave in the chat. Right? So you guys know how to download software. It's simple. Just click download. Yeah, go ahead.
Is there any specific system requirements to use the software?
Yeah. Let me find out there.
And does it work on cross-platform, Windows OS, Linux?
Okay, yeah,
well?
Octave does. Octave works on Windows, Linux, and Mac OS, so you can get there. MATLAB as well. Yeah, MATLAB, I think there are solutions for Mac OS as well, right? But Octave is what I recommend. It's light. And the code is simple, so you can, the same thing we've been typing here, you can translate it over to Octave, right? So let me open up Octave for you as well. So this here is MATLAB. Burn this image into your brain, right? This is how it looks, right? You got your home, you got a thing, you got a command window, you got some folder navigation. So maybe you wanna have a script here, a quadratic script, right? There's a simple function that calculates quadratic roots, the roots of them, right? So you can open up that here and has code inside, and you can do your command window here, or you can run this code, and then there's the workspace and stuff like that, right? Now Octave looks pretty much the same way. Now this is Octave, this is the command window. You can do the same 5 by 8 and you get 40, and you can do y is equal to 50 and it populates there. And if you come over here, the workspace is on the left. So there's ANS, which is the default, and there's y, which is that variable y is equal to 50 that we just assigned, right? So here, and the command history is here, all the different commands we just did. For me, I just did 5 by 8 and y is equal to 50. These were commands I was doing before, right? And of course, CLC clears here, right? And let's say we type some stuff, right? CLEAR clears the workspace, right? So the variables are gone here, but here still has all this junk, and we can type CLC to clear that. So the commands are transferable, right? So if you can get, maybe, I know a lot of people pirate software, so if you want to pirate Matlab, of course, I don't condone that, being a staff of the University of Vienna. Octave is free and open source, and you can use it. So I'd recommend downloading Octave, and it works on Mac OS as well, right? Okay, so whichever one you feel like using, okay? Okay. So let me go back to Matlab. Let me see some other stuff I can show you guys. Okay, so we talked about variables, we talked about workspace, we talked about you doing basic calculations and stuff like that. Now, naming variables. Now, you notice that we can just type y, right, is equal to 4, and that's good. X is equal to 5 or 6. And that's cool. But there's certain things that we need to take into consideration. Generally, when we're naming a variable, we want the name to be meaningful. So let's say we got a group of numbers, like a list of numbers from like a list of 10 numbers. We can make one variable num1, right? Num1, and we assign that to our first number, right? Our first number could be 23. And num2, right? You assign that to our second number, which would be 24. So we can type names out and give meaning to them, right? So that the variable really represents the thing more. So let's say we're doing some calculations, and maybe force, you can use force as a good name, right? Force is equal to 8, right? You can do that to store value. So these variable names would have meaning. Now, one thing you can't do is start with a number, right? So we can do something like 5 force, 4 force is equal to 78. It says that we can't name it like this. We can name it force is equal to 78, but we can't name it 4 force is equal to 78. So we can't put a number at the front. But we can do like force number 2 is equal to 78, right? Force number 2 is equal to 78, right? So we can put a number at the end, but we can't put it at the front, right? Okay, so if you're doing some calculations and you got a lot of forces, right? You can name them force 1, 2, 3, but you can't name them 1 force, 2 force, 3 force, right? Okay, you can also do capital. So you can do like AVG, short for average, and then you can do capital, let me move this up, AVGF, capital forces, okay. It's equal to 90. You can do things like that, right? Common letters and capital letters, and store your variables. All right. Okay. So let's say you were doing some calculations and you wanted to store your variables. Right. So you're doing a set of calculations. You got your average forces and everything, and maybe you want to go sleep, or you want to work on a different problem, right? And you continue this later. What you can do is you can click save, and you can name this file anything, maybe ELE 1214.mat. And what this will do is it will save your workspace into this file, right? So now, if we clear, we lose all of our data, but we can load it back using that. So we see the workspace is populated. We clear, we lose the entire workspace, and we can load it back using that file, okay? 1214. So again, how we do that, we click save, we type save, and then we give the file some name, right? So some whatever file name you want to give it, .mat, right? And then you can load it back even after you clear. Right, so it's a good way to create a safe point. All right. So I think that's enough commands. Let me just go through a simple function with you guys. This is a function that I, of course, typed up in a .m file. So let me just explore it on my basic desktop. So courses, ELE 1214, and I created a file with some code inside, right? Let's just look at it. So this is just a file you can open up with your text editor, and you see I have some comments here. So what comments are parts of the code that won't be executed. Generally, we use comments to explain our code. And of course, these are things I'll go through more in depth as we go about. Today is just a quick introduction of everything, right? So I can type my name here, Neil, using a comment. This is not part of Matlab. Matlab's going to see this percentage sign, and it's going to say, oh, ignore everything after this. Ignore everything in this line, ignore everything in this line, right? So it's going to see that and be like, oh, he's just explaining something to people that want to read the code, right? So that's just my name, Neil Chatterpaul, ELE 1214, this is the class. And this is just a brief description of what the program does. So this is not code. When MATLAB sees this, is not going to try and execute this. From here onwards, though, is code. And what this code does is it calculates the roots of a quadratic function, right? So it takes three inputs, A, B, and C. So in a quadratic function, right, we would have something like 5x squared is equal to 3x plus 2. This is a quadratic function, right? A general form would just be ax squared plus bx plus c, right? So in order to find the roots, we usually take these as inputs, a, b, c, and we use that to calculate the roots using our quadratic formula. So you guys remember the quadratic formula?
Yes, yes, sir.
Yeah, let me just pull it up, right?
Yes, sir.
Good. And then we use those three, A, B, and C, to find out the roots of x, right? So that's what this program does. Let me open up more. What it does, it's a function that takes the input A, B, and C, those three coefficients, and it outputs two values, the roots of the function x1 and x2. That's what we call them. Of course, you can call this squared coefficient, unsquared coefficient, whatever you think would be a good way to put it, right? Yeah. Now I set this up. What I do is I calculate the square root part first. So I use this function sqrt, and I input b to the power of 2 minus 4 times a times c, right? So this here is b to the power of 2 minus 4 times a times c inside that square root function, right? And then plus or minus b divided by 2a, which is this part. So this here is one variable, EIS, the discriminant, I shorten it to DIS, and then this part here minus b plus the discriminant minus the discriminant divided by 2a, and we assign those to x1 and x2, right? And this is just some other code that you could ignore. So what I just introduced is something called a function. Okay, so a function. So let's say we wanted to find out what the square root of 4 is. Square root of 4 is 2. Now this sqrt, open bracket or open parentheses, close parentheses, is a built-in MATLAB function. So what you'll find is MATLAB, like your calculator, has many functions, and of course, even more than your regular scientific calculator. So we can use sine of 90, right? And it will give you 0.894. Of course, this is not 90 in degrees, this is 19 radians, right? Assuming that's 19 radians. So we can do sine of pi, right? Yeah, that declares something. All right. Yeah, so whatever it is, you can just type let's say maybe 16, the square root of 16 minus 4, and you can do calculations, and there are all kinds of different functions in Matlab that we'll, of course, go over as we progress throughout this course. All right, good. So back to the quadratic function. So this function, let me try running it. Going to take 3 inputs, right? This side. Going to take 3 inputs, and those 3 inputs are the coefficients, right? A, B, and C, right? So maybe let's try graphing a quadratic function and see if this program works. Right? Good. So some x squared plus x plus 0, right? So this here is a very simple quadratic function, right? The coefficient is 1 for A, 1 for B, and 0 for C, right? And the roots here are 0 and -1. So let's put that into our quadratic function, right? So we click run. We click run. We type in here run quadratic with 1, 1, 0, right? Then press enter. And here we get, it outputs back x1 as being equal to 0 and x2 as being equal to -1. Right? So I'll send you guys this code as well, so you can look at that and maybe try to understand it a little bit. So yeah, that's it for the introduction for Matlab and Octave. You can do a lot of stuff. You can plot things as well. So let me look at the command fit again. So I can plot X and Y. So let's say we had a list of variables, like an array or a matrix of variables. Let me see how I can write that out. So let's say we just had an array of variables. We had this X is equal to some big array or some matrix, right? So some long list of numbers. X is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And now Y is equal to another long list of numbers, but Y is equal to 2x. So all of these numbers, we multiply them by 2, right? Y is equal to 2, 4, 6, 8, 10, 14, 16, and so on and so forth, right? So these are a list of numbers. What we can do is we can actually plot these, right? We can plot the X values that corresponds to the Y value using the plot command. So just like this calculator up here, which is just a simple tool that allows us to plot functions, right? We can change here to x squared plus 2 and press enter. So this is -2. Yeah, good. And it'll change as we change the function, and it can plot things. And it can also plot lines, right? Y is equal to 5x, right? And it plots a line with 5 gradient, and we can shift the y-intercept. So the y-intercept is 1, right? And we shift the y-intercept up. So similarly, how this would go about plotting functions, we can plot functions as well in Matlab, right? So let's close this. Let's just clear this. Let's say we had X, right? Being a list of values, right? X being a list of values from -10 to 10, but with the increment of 0.1 in between, right? So what this is going to do is it's going to increment by 0.1, and it's going to generate all of these variables for X, right? And you see that it generates a big matrix, right? This is a 1 in the workspace over here, right? This is a 1 by a 201 double matrix. So there's a really big matrix because these are a lot of numbers. It's going to start at 10 and then it's going to increment 0.1, right? Go there, and it's going to increment 0.1, go there, and it's going to go all the way up to 10. Okay, so let's clear this. Let's say 0 to 20, but we increment in steps of 2, right? Let's just press enter. Now we see what this outputs. It's a matrix or an array of 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, right? So you can use Matlab like that to just generate numbers how we would like. So let's say we want to plot the sine function, right? Just quickly. Let's just say x is equal to a group of numbers, right? Incrementing by 0.1. That's a group of number, and y is equal to sine of x, right? And we can just do plot x comma y. And what this does is it plots the sine function, right? Of course, 0 is here and 0 is here, right? For these axes. And there are lots of functions and lots of things you can type to label this, label the x-axis, label the y-axis, and adjust the scale and stuff like that, right? Okay. Okay, good. Yeah, so I see in the chat, you guys worried about all the commands. Of course, I'm going to send you guys a handout and you can practice this stuff on your own, right? Very good. So let me not confuse you guys anymore with everything to learn about Matlab. For homework, what I want you guys to do is download either Matlab or Octave, right? And I'm going to send you guys the handout and I want you to practice this code, right? So I'll send the handout to your class representatives because I don't have the emails for everyone, right? So class representatives, what I'd like you to do is collect a list of all the emails for your particular group. So mech class rep, collect all the mechanic emails, electrical class rep, collect all the electrical emails, all right? And send them to me in an Excel file so that I can communicate to everyone via email. Okay?
All right, sir.
Good. So,
Sir, I joined late, so I just want to make sure something, right? So
yeah.
this here is basically maths and computer science in one, this course?
It's computational software. It's showing you how to use software to do computations. So
Okay.
as an engineer, we find ourselves doing a lot of math, right? As you would notice in most of courses, be it physics courses or electrical engineering courses, mechanics courses, and especially as you go up, you're gonna find yourself doing a lot of math, a lot of heavy maths, right? And the thing is, sometimes it's just not practical to do all of that math by yourself. Sometimes you need a tool that helps you out, right? And Matlab or Octave is a great tool to help you do all that math, help you manage all these numbers, because you can't sit down on a piece of paper and crunch derivatives all night just to figure out how to design something, right? Matlab is just a good tool that can help you crunch numbers faster and get to your final destination quicker, right? Yeah, it's a tool that helps us to do computation, right? Matlab is a tool that's used, it's also used in computer science as well. It's used in a lot of engineering fields, honestly. Like anybody could use it. It's just anyone that does a lot of math would want to use Matlab, right? It can be used for things like machine learning, which is more of an advanced programming concept. It's on its way to like developing AI. What they do is they use neural networks to teach machines how to do things or learn things the way humans would. Like when a baby is born, we would go about learning languages by just picking up sounds and things. You would listen to your mother say mama, 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 and eventually you're going to associate the word mama with your mother. But with computers, we can't do that, right? We would have to say mama equal this person, a picture, right? Because computers are more like rigid instead of malleable or plastic like us. So machine learning is a field that allows us to teach machines to think the way humans think. And MATLAB can be used to do stuff like that. In physics or in engineering, when we do linear regression, you guys know linear regression, right? You have a bunch of values, right? And you can do, there's a bunch of values, right? And you just want a line to represent this, like a line that average, instead of like looking at all these possible data points, you want a line that averages this. You can use machine learning to figure out how to plot this line, right? Yeah, I'll send my WhatsApp number. So MATLAB can be used for a lot of things. And of course, as you've seen just now, you can use it as a calculator. So, and you can use it to solve quadratic functions, find the roots of quadratic functions, and you can write your own programs to do anything. So maybe when you learn about this course more, maybe you can write a program that solves moments questions or solves velocity displacement questions. And you can write functions that do that, right? So as you get higher and you progress throughout your engineering life, you're gonna find that, hey, maybe I can write some MATLAB code to do this homework for me, right? Might be useful when you go out in the field. You might find yourself, I gotta keep calculating resistance all the time for these things, right? Maybe I can write some MATLAB code that does this for me, right? Okay. Okay, I don't think you can solve for the perfect life with MATLAB, but maybe we can get close. Let's see how much we learn. All right, good. So that's the homework. Download this. I'll send you guys the exercise 1. And you'll type the code. You'll familiarize yourself with the layout. Right? Right? Good. Good.
Sir.
All right, good. Yeah.
So are we downloading either or?
Yeah, either
not
or.
both?
Which one you think? Which one you could get your hands on, right?
Okay.
Yeah, Octave or MATLAB. Right? Just Google them. Send back the link.
So this course is gonna give you some an understanding how to write programs in general.
Yeah,
for
it's
like
also going to
projects.
teach you multisim, which is good for electrical engineers that want to design circuits. And of course, you
Yeah.
mechanical engineers did electrical fundamentals and stuff already, right?
Yeah.
And mechanical engineers that might want to go into things like robotics and mechatronics, right? Of course, you're going to use your mechanical engineering aspect to design
Yes, sir.
robots and leverage things like levers and stuff in your robotics. But inside of that are going to be a lot of circuits, right? So there's a circuits aspect to this course. Yeah, someone speaking?
Grandfather.
Who is this person talking to? Was someone saying something?
Sir, wait, sir. You said if we download this MATLAB, we would be pirating the software, right? That's what you're saying, right?
No, the free trial is fine. Right? But after the free trial is finished, what are you going to do, right?
So it's better to download the other one then, sir.
Yeah, it's better to download the other one. Right? But I know a lot of students pirate software. So if you want to use MATLAB, I won't stop you from using MATLAB, right? It's good. I mean, it has some things that are nicer. So you might want to use MATLAB if you want. It's up to you what you want to do, right? So you can sign up for a student copy of MATLAB and try it out, see if you like it. All right?
But sir, would the trial be up before this course is out?
What file?
Would the trial for the MATLAB be up before we finish this course?
I think the trial is 30 days. I don't know if it's more than that.
Wow, definitely the other one then, sir.
Yeah, Octave is great. Right. I want to go through Simulink as well. So Simulink is a part of MATLAB. MATLAB is not just the programming language, it's this environment. And in your third year, both mechanical and electrical engineering students, you guys are gonna learn about control systems, right? It's just a way of how we abstract different components. So when you think of a car, right, there's a lot of different parts in it, right? There's the engine, there's the transmission. So what control systems teach us to do is to let's just draw a box around that and say, this functional block, the engine does this. It takes in gasoline and it outputs force, right? So we just draw a box of basic inputs and outputs, and we can put those functions into Simulink and simulate really complex stuff. So Simulink is used both for electrical engineers, mechanical engineers, even civil. Whoever does control systems can use Simulink. Simulink is a great tool. So I'll touch on that a little bit after we finish learning the basics of MATLAB. All right. So yeah, that's it. That's all I have for you guys. I'll send the file now to your class reps. All right.
Yeah. So,
Yeah.
the class rep have your number? Contact you in case the class has any issue.
Yeah. Okay. Let me put my email up so
Or your
anyone.
email, yeah.
Yeah, let me get an email.
So write it in the chat, sir.
Yeah. Yeah. Metal machining. Obed James, are you talking about like CNC? No, MATLAB is not used for that. Maybe something like an Autodesk software, AutoCAD and stuff like that. Did you guys do an AutoCAD course, an Autodesk AutoCAD course?
Not as yet, sir.
No, sir.
When are you guys supposed to do it? Second year?
We don't know. Nobody never tell us about that.
You guys do drawing?
Mechanics student is sir.
Okay. All right, yeah, so yeah, you can use the same, usually the same software you draw with, you can use it for CNC. So you got a CNC machine and you would create your drawings in AutoCAD or whatever, and then you send out the CNC software. That's gonna convert it and send it out to your CNC machine, and that's gonna cut out the metal, right? Maybe I can teach you guys some AutoCAD basics as well. We'll see how much time we have throughout this course, right? Okay. Yeah, good. So that's it. Roland, did you receive the files?
Yes, sir. I just received it.
Sarah, let me send it to you.
Oh, so sorry. So this is your number here.
Yeah.
All right. I just didn't have a name to it.
Okay, great. Yeah, and Sarah, you received the files as well, right?
Yes, sir.
Okay, good. Hmm? Someone's breaking up. Yeah, the person's breaking up. What are you saying, Moodle? Just type it in the chat, please. I can't hear you. Mic is quiet. Yeah, again, I just can't hear you.
Sir, when's our next class?
Friday. Yeah, we're gonna do 2 hours. Okay, so make sure you guys
Excuse me, sir.
download. Yeah.
Can you please send the download file to my WhatsApp?
What download file?
No, the download link for the that you shared in the chat.
Okay, send it to Roland.
Yes, sir. So
All
I
right,
can
good.
share it in the WhatsApp group.
Okay, good.
Yes, sir. Thanks.
Good. All right, anything else? Remember, download, practice, familiarize yourself with software. Just play around, right?
Yes,
Nothing
sir.
too fancy. Do some basic calculations. Maybe you can try doing 1-year homework questions from another course, you know, some mechanical course, some course you can try doing, okay?
Sorry, so you'll send us the handout before the end of the day?
I sent it to a class rep, so your class reps will forward it to you.
Okay, okay.
Yeah, I just forwarded it to my electrical group.
So yeah, mechanical students, right? You guys gonna get it from Sarah, right? So class reps, please collect all the emails so that I can get everyone.
Yes, sir. So I'm going to compile it and send it to you later on.
Yeah, good, great. Okay, so that's it. Thank you guys for coming. Download the software,
All right.
practice the material. All right, great.
Yes, sir. Thanks, sir.